Welcome to the PrepNet, presented every Sunday at 6 p.m. Eastern Time on Talk2Me's Channel 14. Come join us to discuss everything about prepping and hear what others have done. All about electricity. Part 5. Large Battery Bank Basics. This segment will be about battery banks that contain many 100 amp hour or larger batteries. You need to have a basic understanding of the different configurations of battery banks before you can design your own to fit your needs. Regardless of how you charge your battery bank, there are many things you need to know about battery bank differences. There are so many things you need to understand before you can design your battery bank that it's hard to determine where to start, but I'll do my best. First, some basics. We all know a 12-volt system is not exactly 12 volts. It's just the easy way we refer to a system that provides a nominal voltage of 12.8 volts and up to 14.2 volts maximum when fully charged. Your car has a 12-volt system, and it's a very common voltage for a battery bank. For your battery bank, the voltage is important, but what is more important is the capacity of the battery bank. This is noted as amp hours and will allow you to calculate what you can run and for how long. What are amp hours? The simple example is, if I draw 1 amp to run a light from my battery bank and run that for 1 hour, that equals 1 amp hour. If I have a 100 amp hour battery, then on paper, I can run that 1 amp light for 100 hours. If I run 2 of those lights, the battery can run them for 50 hours, etc. If the battery bank you have is not big enough to power what you need, you can increase the total amp hours of the battery bank. To have more capacity, you can connect many 12-volt batteries in parallel to get more capacity or amp hours. Connecting batteries in parallel means connecting positive to positive and negative to negative. The voltage will remain the same, but the amount of power or capacity will increase. One example, if you connect 2 100 amp hour 12-volt batteries in parallel, your capacity will now be 200 amp hours at 12 volts. That's 100 amp hours times 2, which equals 200 amp hours. You will be able to run more items at one time or run more power-hungry items. Another example would be connecting 4 100 amp hour 12-volt batteries in parallel. The capacity would be 400 amp hours at 12 volts. That's 100 amp hours times 4, which equals 400 amp hours. In our two examples, these 200 to 400 amp hour battery banks will allow you to run things longer or allow you to run more electricity-hungry devices. However, running the more electricity-hungry devices will pull more amps, which will require larger and more expensive cables so as not to cause wire overheating and a fire. It is very important to size the wires between the batteries and the wires from your battery bank for safety and with the least amount of voltage and amperage losses. The more amps you draw, a larger size of wire is required. I will not cover this here since there are many factors involved, and I could not cover them all. At some point, a 12-volt battery bank will not fit your needs, so what can you do? There are also 24-volt and 48-volt systems used in battery banks, and they have some advantages over a 12-volt system. So how would a 24 or 48-volt system help me? First, an example of how much current is drawn from a 12-volt, 24-volt, and 48-volt battery bank. If I need to run a 1500-watt AC heater from a 12-volt system, it will draw 125 amps at 12 volts. To run that same 1500-watt AC heater from a 24-volt system, it would only draw 62 amps at 24 volts. This would require smaller wires than with the 12-volt system. And running that same 1500-watt AC heater from a 48-volt system would only draw 31 amps at 48 volts, requiring an even smaller sized wire. This subject will be discussed in more detail when we talk about large lithium iron phosphate battery banks. Now, there are not that many 24 or 48-volt batteries, so how do I create them? Connect 12-volt batteries in series to increase their voltage to either 24 volts or 48 volts. An example of a series connection is, take 2 100 amp hour 12-volt batteries. Connect the negative of one 12-volt battery to the positive of the second 12-volt battery. Now connect your 24-volt load to the unused positive of the second battery and the negative of the first battery. You now have 24 volts at 100 amp hours, which requires a smaller wire to your load. Our 48-volt example would take four 100 amp hour 12-volt batteries, connecting them in series to make a 48-volt battery bank. The positive of battery 1 would be connected to the negative of battery 2. Then the positive of battery 2 would be connected to the negative of battery 3. The positive of battery 3 would be connected to the negative of battery 4. Connect your 48-volt load to the unused negative of battery 1 and the positive of battery 4 for a voltage of 48 volts at 100 amp hours. An important note here: the components you use in your battery bank must be able to handle the same voltage as your battery bank. This includes charge controllers, solar panels, DC circuit breakers, DC to DC converters, DC to AC inverters, and DC voltage and amperage meters. Don't connect a 12-volt DC to AC inverter to a 24-volt battery bank, etc. More details will be in future sessions. Now, to provide even more capacity, you can connect your batteries in a series parallel configuration. In series to create 24-volt batteries, and in parallel to increase the total amp hours of the battery bank. We'll create my first 24-volt battery bank using 6 12-volt 100 amp hour batteries. Make a 24-volt battery from 12-volt batteries 1 and 2 by connecting the positive of battery 1 to the negative of battery 2. Make a second 24-volt battery from 12-volt batteries 3 and 4. And finally, a third 24-volt battery from 12-volt batteries 5 and 6. Now connect the unused negative posts of each 24-volt battery to the negative bus bar. Next, connect the unused positive posts of each 24-volt battery to the positive bus bar. Connect your load to the negative and positive bus bars to use your new 24-volt 300 amp hour battery bank. I hope this explains the different battery bank configurations you can use in designing your emergency electric backup, including the voltage of your battery bank and the amount of amp hours needed. Next week, we'll continue our All About Electricity series and discuss using large lead-acid batteries. If you have any questions about what we have discussed here tonight, please send your question to prepnetch14@gmail.com and enter question in the subject line.